So the last of our special points that we are going to talk about is the orthocenter, which is the point of concurrency of the lines that contain the altitudes. So if you find the altitudes of the triangle and you figure out where they intersect, you have the orthocenter. The example we're going to look at is an example of finding the orthocenter of a triangle. So we are given that triangle ABC has vertices at A13, B27, and C63. And we're going to use that to find the orthocenter. So the first thing we need to do is graph these points. So we need to graph the points 1, 3, 2, 7, and 6, 3. So the point 1, 3 would be 1 to the right and 3 up. The point 2, 7 would be 2 to the right and up 7. And the point 6, 3 would be 6 to the right and up 3. So that would be our triangle. We are looking for the coordinates of the orthocenter, which is where the altitudes intersect. And the altitudes go from the vertex of each vertex of the triangle perpendicular to the opposite side. So if I go from the top vertex there since the bottom of the triangle is horizontal, we're going to have a vertical line that's perpendicular to that, right? So we go from the top vertex perpendicular to the opposite side. Okay. Now we have to pick another vertex, like this one, let's say. And we have to go perpendicular to the opposite side. Now, it's been a while, but if we want to be perpendicular to this line, count the slope from this point to this point. We'd have to go down 1, 2, 3, 4, and over 1, 2, 3, 4. So the slope of this line is what? So our slope of BC is -1. Opposite of that would be positive, and the reciprocal is still 1. So the slope of our line that is perpendicular to that also has a slope of 1. If I draw that in, going from this point right here, slope of 1. Where do those two lines intersect? So they intersect right here, right? Which is the point 2 to the right and up 4. So our answer is 2. The point 1, 2. Means we go 1 right and 2 up from the origin. The point 1, 6. We go 1 right and up 6. The point 4, 2. We go 4 right and up 2. So here is our triangle. What is the slope of line segment DF? 0. So the perpendicular slope is vertical line. So if we're going from DF, we're going to end up at E. So we're going to draw a line from E perpendicular to DF. Now, since we are looking at being vertical, here would be our altitude. I'm just going to extend that a little bit. Now, the other slope that's going to be relatively easy to identify is DE or ED, because that slope is undefined. It's a vertical line. So what's perpendicular to vertical? Horizontal or zero slope. So the slope of DE is undefined. It's a vertical line. So we want to do a horizontal line from DE that goes through F. Which would be that line. And where do those two lines intersect? Yep, at point D, which is the point 1, 2.